Hello friends, welcome to my YouTube channel. So in this video I'm going to explain field density by using core cutter method. Core cutter method. Determination of in situ dry density by using core cutter. By using the core cutter we can determine the density of the soil sample. So the reference code is taken as IS 2720 part 29. The reference code for determining of core cutter is IS 2720 part 29. From this code we can determine the core cutter. So coming to apparatus required for determining the core cutter is cylindrical core cutter, a steel hammer, a steel dolly, a weighing balance and a steel ruler. So coming to procedure for determination of the core content of the soil sample. Coming to procedure, first we have to determine the internal diameter and height of the core cutter. Our first step is we have to determine internal diameter and height of core cutter. So first we have to measure what is the diameter of the core cutter and what is the height of the core cutter. Our second step is we have to determine the cylindrical core cutter weight without the dolly on top of it. Our second step is we have to determine core cutter weight without dolly. We have to determine the core cutter weight without dolly. By removing the dolly from the top, we have to determine the weight of the core cutter. Our third step, we have to level the surface where the test has to be conducted and place the dolly over top of the core cutter and press the core cutter into soil mass using the rammer. First of all, we have to level the surface where the test is to be performed. First, we have to select a ground surface and we have to level the surface where the test is to be performed. Means at which place we are going to perform the test. First we have to select the place and we have to level the soil surface and place the dolly over the top of the core cutter, and we have to place dolly over top of core cutter. On the top of the core cutter we have to place the dolly and press the core cutter into soil using a rammer, and we have to press the core cutter into soil by using a rammer. Means by giving the blows from the rammer we are going to press the core cutter into the soil sample. We have to stop the process of pressing when the dolly protrudes above the soil surface. We have to stop the process of pressing the dolly we have to stop this process until the dolly protrudes above the soil surface. Means whenever the dolly is coming above the top of the soil surface, then we have to stop the pressing of dolly into the soil surface. Remove the surrounding soil of the core cutter and take the core cutter. The end of the soil core is trimmed to the straight edge. Our final next step is we have to remove the surrounding soil of the core cutter. So whenever the core cutter is pressed into the soil, we have to remove the excess soil or the surrounding soil around the core cutter, and we have to take out the core cutter. Take out the core cutter and we have to trim by using a straight edge, and we have to trim the core cutter using a straight edge. Our next step is we have to weigh the core cutter filled with the soil. We have to take weight of the core cutter plus weight of the soil. Our final step, remove the core cutter of the soil from the cutter to determine the water content. Next we have to take some soil sample from the core cutter for water content determination. Okay, so once again I'm going to explain the procedure. First step is we have to determine the internal diameter and also the height of the core cutter. Next we have to determine the core cutter weight without dolly. Next we have to determine the weight of the core cutter without dolly. Next we have to level the surface where the test is to be conducted, and we have to place the dolly over the top of the core cutter, and we have to press the core cutter into the soil mass by using a rammer. We have to stop the process of pressing the dolly. We have to stop the pressing of the core cutter into the soil when the dolly is protruding above the soil surface. Next is we have to remove the excess surrounding soil. We have to remove the excess soil which is surrounding the core cutter, and we have to take out the core cutter, and we have to trim the edges of the core cutter by using a straight edge. Next is we have to take the weight of the core cutter along with the weight of the soil which is filled in the core cutter. Next we have to take the sample from the core cutter for the water content determination. So this is the procedure regarding the determination of the in situ dye density by using the core cutter. So for determination of the water content, there are two tabular forms we can be taken. Coming to observation table or observations, we are going to take two tabular forms. In our first tabular form, we are going to determine internal diameter of core cutter. Next is internal height of core cutter. Next is weight of empty core cutter. Next is weight of core cutter plus soil. Next is only the weight of soil. For getting the weight of the soil, weight of core, for getting the weight of the soil, weight of the core cutter plus soil minus weight of the empty core cutter, we will be getting the weight of the soil. Okay. Next is volume of core cutter. Volume of core cutter is equal to pi by 4 into d square h. So this is one observation table regarding the core cutter method. First is internal diameter of the core cutter taken in centimeters, internal height of core cutter taken in centimeters, weight of the empty core cutter, it is taken in grams, weight of the core cutter with soil taken in grams, weight of the soil, for getting the weight of the soil, weight of the core cutter plus soil minus weight of the empty core cutter, we will be getting the weight of the soil. Next is volume of the core cutter. This is the normal observation table regarding the determination of the core cutter. Our next observation table is for determination of the water content. For the determination of the water content, first of all we have to take the weight of the container. Next we have to take the weight of the container plus wet soil. Next we have to take the weight of the container plus dry soil. Next we have to take the weight of the water. Next we have to take the weight of the dry soil, and final the moisture content in percentage. The weight of the water is WW and weight of the dry soil is WD. For getting the moisture content, weight of the water divided by weight of the dry soil will be getting the moisture content. Hope you like this video. Please subscribe to my YouTube channel. Thank you everyone.